Hi, in this video we are going to learn the 8th program, de- design and develop a code and run the program in any suitable language to solve the commission problem. Analyze it from the perspective of decision table based testing, and also we need to derive the different test cases and execute these test cases, and we need to discuss the test result. This is the program where we have to write the code for commission problem, and then we need to write the decision table based testing technique, and based on the decision table we have to write the test cases to test that code. So this is a decision based table is one of the uh, black box testing technique. So that testing technique we are using under this program. So here the point number one is, so first we need to write the requirement specifications of the given program. So the system first requirement specification is the system should read the number of logs, stocks and barrel which are sold in a month. Then the maximum number of logs, stocks and barrel value will be varies from 1 to 70, 1 to 80 and 1 to 90. This is the first requirement specification, where in a month we can sold the maximum number of log size 1 to 70, and the maximum number of stock is 80, and maximum number of barrel is 90. The second requirement specification, if requirement 1 is satisfied, so based on the requirement 1, so if it is satisfied, then we will move to the requirement specification 2. The system should compute the sales person's commission depending on the total number of logs, stocks and barrels sold. Else it should display the suitable error message. So the following will be the percentage of commission how we are going to calculate. The 10% on the sale up to 1000 rupees, and 15% of the commission we are specifying for the next 800 rupees, and 20% of the commission will be given so more than 1800 or 1800 to greater than 1800. The system should compute the total dollar sales and the output sales, total dollar sales and his commission. So based on this is what the requirement specification of the commission problem. So next we will move to the after requirement specification. We need to design the code. So while designing, so in the designing specification we are writing the algorithm of the program. The step 1, we need to specify the unit price of the log, unit price of the stock and unit price of the barrel. The log, stock, barrel unit prices are 45, 30 and 25 respectively. Next, the user will give the input for a system, that is logs. If the log value is -1, then the program needs to be terminated. That indicates that the end of the sale. The -1 value indicates that the end of the sale. End of the sale is nothing but program has to terminate. The termination of the program will be specified if the log value is -1. So therefore in the step 3 we are going to check whether log value is -1 or not. So after that, based on the log value, so then it will move inside the looping statement, and in the looping statement we are extracting the value of stocks and barrels, and then we will calculate total log, total stocks and total barrel value. And then so once again the while loop statement will ask input of the logs. If the input of log is not -1, then the same it will ask log, stock, barrel value, then it will once again calculate the total logs, total stocks and total barrel. This is how a looping statement will work. Once if we specify input of logs is -1, then the program will be terminates. Next step is we are going to calculate the total sale value based on commission. Commission is nothing but 10%, 15% and 20% commission. So here the total sale equal to total logs into unit price plus total stocks into unit price and plus total barrel into unit price. Then we are going to get the value of total sales. So in the step 5, so based on the total sale value, we are going to calculate the commission. If the total sale value is less than or equal to 1000, it indicates that 1 to 1000. So if the total sales value comes under the 1 rupees to 1000 rupees, then the percentage of commission will be a 10%. first 1000 rupees we are giving a 10% commission. Therefore, the commission equal to this formula we are using, the commission equal to 0.10 into total sale. So if the commission value is not within 1000, if it is greater than 1000 and less than 1800, then it comes under the next category. So here first we will specify the first 1000 rupees we are giving 10% of the commission, and rest all remaining 800 rupees we are specifying or we are giving 15% of the commission, or we are calculating 15% of the commission. So therefore here we are having two expressions or formulas. One is for calculation of the commission and one is for the calculation of the 10% and 15%. So now commission equal to 0.10 star 1000, that is first 1000 rupees we are giving a 10% commission. Next we have to calculate the 15% of the commission for next remaining amount, that is in between 1001 to 1800. So for that the formula will be commission equal to commission plus 0.15 star total sales minus 1000 rupees. This is a commission what we are calculating for if the value is in between 1001 to 1800. Else if commission value or total sale value is not in between if statement and else if statement, by default it will comes under the else clause. In the else clause, it indicates that the amount might be or total sale value might be greater than 1800. Once it is greater than 1800, then the formula will be these three. First we have to calculate a 10% for first 1000 rupees. Next 800 rupees we need to calculate the 15% of commission, and next remaining amount we need to specify 20% of the commission. This is the three formulas which we are using to calculate the commission for the total sale. Then we have to print the total commission or else total sale along with the commission. This is how, so we have designed a description based on the requirement specification. After that we have to write this code, so program code. So this is a C programming language. Here we have written a C code, so you can go through with the C programming. So the same manner we have written that code. Once this code is written, if the code is executable properly, there is no any errors or bugs, then we can proceed with the test cases. The test cases is nothing but here we are applying a technique, that is decision table technique. Then in the previous video I have explained how to write the decision table technique. Based on that the same technique we are applying over here. So for a commission problem, using the decision table we get a 6 functional test cases, 3 cases out of range, 1 case is for sales greater than 1800 and 1 case is for greater than 1000 and 1 case is for less than or equal to 1000. So here totally we will going to get the 6 functional test cases. Out of this, 3 test cases are like this. 1 test case is to calculate the greater than 1800, 1 test case is for calculation of the greater than 1000 rupees, and 1 calculation is for calculating of a equal to 1000, that is nothing but 1 to 1000 and 1001 to 1800 and greater than 1800. Now I will explain how to write the decision table for this commission problem. Now I have explained that basically the decision table includes 4 partitions or 4 parts. One is stub portion and second one is entry portion. The stub portion once again which will be contains 2 portions. One is action portion and second one is condition portion. Condition portions are nothing but based on your problem statement we are writing some conditions. So this is what we are calling it as a condition portions, and this is we are calling it as an entry portion. In between condition portion and action portion there will be a one rule count. You can see here rule count. The rule count will give a clear picture how many test cases we are going to write, or else how many test cases probability we have done. That indicates by the rule count. The rule count formula to calculate the number of rule counts in a given program is 2 to the power of n. where n indicates number of conditions. Okay. So here, how to write the condition? We know that the lock value should be lies in between 1 to 70. This is our first condition. Second condition is similarly the stock value should lies in between 1 to 80, and the barrel value will also lies in between 1 to 90. These are the first three conditions. If whatever the value we are giving for your program, the value should be within this range. If the value is out of range, then the program has to terminate automatically. So first, if these three conditions are satisfied, then only we will move to the condition 4 or condition 5 or else condition 6. In case if these three conditions, if any one of the condition becomes false, means the values are outside the range. Okay. So therefore conditions it is not satisfying over here. So now let us consider, so C1 is lock value, C2 is stock value, and C3 is barrel value, and C4 is a next calculation, C5 is next condition, and C6 is next condition. Now let us consider how to write the entry portions. So this is the what entry portions. These entry portions we have to enter the values in the Boolean function, either true or false manner. So how to identify R1, R2, R3, how many number of rule counts are there? Based on your rule count formula, we need to identify the number of rule counts, whether it is R1 or R2 or R3, how many number of rules should be there, whether R1 to R6 or whether R1 to R10 or whether R1 to R11. So now I'll tell you how to write C1, C2, C3. So if R1, let us assume that first time the lock value is false. The false means it indicates the lock value is not within this range. It is outside the range. Either it is greater than 70 or it is less than -1 or else 1. So less than 1 means, so the value which will not comes under within the range. That is the meaning of F. Now consider if condition 1 itself will becomes false, then no need to go for the remaining condition, means there is no need to check the remaining conditions, or there is no need to give the values for the remaining conditions. Therefore those are all written by the dashes. These dashes are indicates that don't care conditions are not required to represent, okay, not applicable. So that not applicable will be written in this fashion. So therefore, so remaining conditions are written it as a dash dash dash. Next time, next C1 condition for the rule 2, let us consider previous time it is false, now I will make it as a true. Okay, next time I will move to the condition 2, condition 2 will becomes false. Next time condition 2, that is stock value, stock value is, now stock value is outside the range. Once I told initially C1, C2, C3, if these three conditions are satisfied, then only we will go for C4, C5, C6. If any one of these three conditions are false or failure, then we are not going to check the condition C4, C5 and C6. Now what happened? C2 becomes false. Therefore, these other remaining conditions will becomes false. That is, I have written it as a dash dash dash, means don't care what is it is not applicable, that will be written it as a dash dash dash. So next time next C1 will be always true. Next remaining how many times we are writing the rules, so that's those many number of times it will becomes true. Next second condition is there, next time I will make this one as a true, and third condition I will make it as a false. Done. So same condition, C1 is true, C2 is true, but now the time is C3. C3 becomes false. So out of C1, C2, C3, any one of the condition becomes false means what? Remaining conditions are not applicable. Therefore here I have written a dash 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 for C4, C5 and C6 conditions. Next time C3 condition will becomes true. Means now you can see C1, C2, C3 becomes true. Then so either C4 should be true, or C5 should be true, or C6 should be true. So concentrate here. So when C1, C2, C3 conditions are true, then I need to check the condition C4, C5, C6. Out of these three conditions, So one condition will be true and remaining conditions will be false. Remaining conditions will be false or else it is not applicable. Is that clear? So now, so I'll move to the R4. Here you can see T1, T2, T3, all the conditions are true. Then I will make C4 as a true. If I make this C4 as a true, so I won't get the output result which the total sale value which are comes under uh, greater than 1000 and as well as less than or equal to 1000. Now the value I got a total sale value more than 1800 or equal to 1800. Therefore, once this will becomes true, then these two conditions will be not applicable. Similarly, move to the R5. R5, so now I will tell you how to write the rule count. Rule count, I told the formula is 2 to the power of n. So here how to write how many test cases are gone or over completed. That 32 test cases are checked under this particular R1 column. Similarly in the R2 column 16. So how many not applicables are there? That is a value of n. 2 to the power of 1, 2, 3, 4, 5. 5 is there 2 to the power of 5. Then 2 to the power of 5 is nothing but 32 test cases are over. Here 16 test cases are gone. Here 8 test cases are gone. Here 4 test cases are gone. Means already tested, it indicates. So now here 1 is there, 1 dash is there. So now I am talking about this. Uh, Here how many dashes are there? 2. Then 2 to the power of 2. 2 to the power of 2 means total rule count value will be 4. Okay, next R5. Now these three will be true. Now, so this C4 will becomes false. Then C5 should be true. I told one condition can be true, other condition should be false or else it should be a not applicable. Now this time I have C5 I have made it as a true, but C4 should be false, and then automatically I won't check the C6. Why? Because C5 is already true, then no need to check the condition for the C6. Therefore it will be represented as a dash or not applicable, or else that will be indicated by dash. So then last is R6. All first three conditions are true. Then C4 and C5 should be false, and then last one is C6 should be true. When C6 will be true, then there is no any dashes. When there is no any not applicable column, then that rule count will be always 1 of that particular column. So then it is represented by using a 1. Now you can have a count. So how many conditions are there? Total 6. Then 2 to the power of 6. 2 to the power of 6 is nothing but total 64. 2 to the power of 6 is nothing but total 64 test cases must be present. But here how many test cases are done? You can count it here. 32 plus 16 plus 8 plus 4 plus 2 plus 1. Total 63 test cases are over. Then what about the remaining one test case? The remaining one test case which will be explains. So let us consider here R7 rule count is there. R7 rule count, here if I write true, 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 next combination of C4, C5, C6 will be a false, false, false. Is it all can be a false, C4 and C5, C6, if these three conditions are true? No, it is not possible. So means practically we can't write here, but theoretically I can show you that here you write R7, then here T, 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 then write false, false, false. When these three conditions are true, I am repeating, when C1, C2, C3 conditions are true, at least C4 or C5 or C6, any one of the conditions should be true. So should be true, but it should not be a false. It can't be a false. Why? Because when we are giving a all valid input variable within a range, definitely our program will calculate the commission. For that commission we will total sale. For that total sale we will calculate the commission. Once if you calculated the total sale, then automatically the value will be either within these three conditions. Either the value might be a greater than 1800, or else 1001 to 1000, or else less than or equal to 1000. Okay, so therefore, so if you want to write one more test case, the one more test case can be a R7. R7 is nothing but first three conditions are true, and remaining C4, C5, C6 conditions, if it is false, then it is a meaningless of the column. That is nothing but it won't give a correct meaning. Why? Because when these three conditions are true, either I need to get C4 as output result, or C5 as output result, or C6 as output result. Here if I am writing false, false, false for 3 C4, C5, C6 condition, then it is a meaningless of writing the that condition. Therefore, here we will be generating only 63 test cases instead of 64. Clear? Then, so here it is a action portion. Action portions are represented by using a small a. Here 4 output result we are generating. One is to calculate the 10% sales, one is to calculate the 15% of the sale, one is to calculate the 20% of the sales. Then last one is there, if values are lesser than or greater than the given range, then it should be out of range. Then the value should be out of range. Okay. So now the condition 1 is false. Then what is my output result? It indicates that lock value is out of range. Lock value is out of range means then in that particular column I need to put a cross mark over here for this action. Next, similarly R2, C1 is true but C2 is false. False is nothing but what? The stock value is out of range. Once the stock value is out of range, my output result will be what? Out of range. Here you need to put a cross mark. Then R3, first condition and second conditions is false, then third condition is true, third condition is false. Once this barrel value becomes false, it indicates that it is out of range. Once it is out of range, then once again I am going to generate the output result A4. Then if all these three conditions are true, so then any one of C4 or C5 or C6 should be a true. When C4, C5, C6 should be true means in that I can, first time I will make C4 condition is true, next time I will make C5 condition is true, next time I have made it as a C6 condition as a true. Okay. Now if this is the condition true means then greater than 1800, that sales value is greater than 1800 means I need to get or I need to calculate commission for 20%. So therefore wherever the formula 20% is there, you need to put a cross mark for that respective column. Okay. Next, here this one is the true. So this is true means the total sale value is greater than 1000. 1000 is nothing but what? 1001 to 1800. Then the commission I need to calculate 15%. The 15% wherever action 2 is there, it is calculating 15%. Therefore in the respective column put a cross mark on that particular action portion. Then last one is there. So R6, in the R6 this is the true. Once this is the true, indicates that the sales value is less than or equal to 1000. Once it is less than or equal to 1000, so output result will be a 10% of the commission. 10% of the commission is nothing but I need to put respective X mark over here. The X mark indicate that corresponding output result we are going to generate with respect to the conditions, and then this is the action. So I think this is the how we need to enter the decision table. I think it's cleared. Now I will move to the test cases. How to write the test cases? How many test cases should be present? Here how many outputs are there? 1, 2, 3, 4, 5, 6. Means total 6 test cases we are going to generate under this decision table technique for your commission problem. Okay. Now, so now I'll move to the, so here I will tell you, here we are having a 9 test cases. I'll explain you why I have written 9 test cases. I told here 6 test cases, correct? Okay. Now, so first one is what? The lock value should be out of range. In this order only you need to write the test cases. This is the first test case, this is second test case, third test case, fourth, fifth, sixth. In this order only you need to specify the test cases. Now the first value is lock value should be a what? Outside the range. Outside the range lock value means what? So testing for requirement 1, that is R1. If it is R1, the condition 1, C1 should be a true. False. So now lock value should be outside the range. Outside the range means -2. Here I have not written -1. Why? Because that will be a termination of the program. Therefore -2 is considered as a invalid input for your lock value. Okay, and stock barrel value should be a valid input variable, that is nominal. Clear? So then next time, this is the lower limit of lock. Then similarly I need to jump for upper limit. 70 is the upper limit, then more than 70 I need to specify. Here I can specify 71, 72, 73, 74. That are all we are calling it as a higher or upper limit. So means I am writing the two test cases for lower limit and upper limit test cases for your 1 output result. Therefore I am generating here 9 test cases. Here 2 test care for this decision, 2 test cases for this decision, 2 test cases for this decision. Total 6 test cases are gone. Then so these 3 test cases are 1 test cases for these 3 output results. Therefore total I am generating a 9 test cases. I think it's clear. So for condition 1 only I am writing a 2 test case. One is lower limit and one is upper limit. Okay, so lower limit means invalid input of the lower limit, invalid input of the upper limit, and other 2 input should be a valid input variable, that should be a nominal. Similarly now I'll move to the condition 2. Condition 2 is nothing but, now I need to make it as stock value should be a false. So stock value should be false means 2 test cases, that is, so lower limit of stock and upper limit of the stock. Lower limit of stock is, here you can specify -1 or -2 or -3. Here you can also specify 81, 82, 83, 84, any value greater than 80. So if these 2 test cases I have written, so here other 2 inputs are nominal values. Okay, similarly I need to jump it for uh, condition 3. In the condition 3, barrel value should be outside the range. So here you can see barrel value is one corner is lower corner. Either you can specify -1, -2, -3, -4, -5, any value. Here you need to specify more than 90 or else 91, 92, 93, 94, anything whatever you want. That should be invalid upper limit, invalid value of upper limit. Here so lower limit of the, so invalid input variable. After that I need to specify the value valid input variable, where so in such a way that you need to specify the input where my total sale value should be a greater than 1800. To get a greater than 1800, it is not mandatory that you need to specify these values. You can specify any value, whichever the value you want. So based on that you can generate. Here so I'm specifying here 25, 25, 25 lock, stock and barrel value. Here you can see my value is greater than 1800. So if I'm generating greater than 1800, so now my commission is, so I'm getting a commission 360 rupees. So this is the how I need. Sir, you may ask the question, we have to specify 25, 25, 25. No, it is not mandatory. You can change the value, but the you need to get a total sale amount is there. This amount should be a greater than 1800 in such a way that you need to specify the value. Similarly, so for this test case, I have to generate 15%. To generate the 15%, the value should be greater than 1000 and then lesser than the 1800. In such a way that you need to specify. You can see, so I have specified 15, 15, 15. Now I am getting a value 1500. If you are generating 1500, then it comes under 1001 to 1800. Then it is a test case for your next. The last test case is the total sale value should be less than 1000. Less than 1000 is nothing but you can specify either 555 or 222 or 111, whichever the value, valid input variable only you need to specify. Once if you specify valid input variable, then the total sale value is there, that should be lesser than 1000. If you are specifying this value, then this will be the test case. If all the test cases are passed, then my total test case table is done. So then execute it and check it. If it is a expected output result you are getting as an actual output result, then the status will be a pass, or else some bugs are there in your code that you need to identify. This is what test case execution and result of the test cases. How many number of test cases we have written? 9. Number of defects rise 0. Number of test cases are passed 9, and number of test cases failed 0, 0, 0. So here there is a one note is that the commission problem is not well served by a decision table analysis, because I told here, so one test case is lagging here. Why? Because uh, it has a very little decisionals, because the variables in the equivalence classes are truly independent. No impossible rules will occur in a decision table in which the condition corresponding to equivalence classes as compared to equivalence class. That is one of the drawback of your commission problem. So this is about your how to write the decision table for your commission problem. Clear? Any doubt? Please comment, share, and subscribe my channel.